So now let's continue our discussion on percentiles with another example. So what I have here is a data set with 30 observations. These observations have been arranged in ascending order. So the first observation is 0, right? The second observation is 0.5, the third observation is 1.1, and so on and so forth. So these are the xi. We would like to find the values of the three quartiles. And I haven't talked about this, but in any data set, there are three quartiles. We have the first quartile, which is denoted by Q1, and it's the 25th percentile. The second quartile, which is denoted by Q2, is the 50th percentile. And then the third quartile, which is denoted by Q3, and it's the 75th percentile. And as you will see in a little bit, the second quartile, so Q2, which is the 50th percentile, is exactly the median that we have talked about. So let's go ahead and do this problem. Let's look at the 25th percentile. Now the data points have been arranged in ascending order for us, so step 1 has been taken care of. So now we want to find the index. We want to find the index I. The index I in this case is going to be P divided by 100 times the number of observations. So P over 100 times N, right? P in this case is 25 divided by 100 times the number of observations. Here we have a total of 30 observations. If you do the math here, this gives you 7.5. Now 7.5 is not an integer, so what you want to do is you want to round up to 8. And so the 25th percentile is going to be the 8th observation in the data set. And if you look in the table here, the 8th observation in the data set is 2.8. So 2.8 is the value of the 25th percentile. So technically, this is our third step. Right? So step 3 is right here. Okay. So now that was the 25th percentile. Let's now look at the 50th percentile. So we start by finding the index, which is equal to P divided by 100 times the number of observations. So here we have 50 divided by 100 times 30, and that's going to be 15. So then in the third step, because I is an integer, the 50th percentile is going to be equal to the average of the 15th and the 16th observation. So it's going to be x sub 15 plus x sub 16 divided by 2. So that is 5.2 plus 6.1 divided by 2. That gives us 5.65 as the value of the 50th percentile. Now let's apply the same procedure to find the 75th percentile. So 75th percentile, I'm gonna go through this really quick here. The index I is gonna be equal to 75 divided by 100 times 30. That gives you 22.5. Okay. Then in step 3, you want to round that up to 23, and so the 75th percentile is going to be equal to the 23rd observation, which according to our table is going to be equal to 8. Okay. So one thing I want to note from this exercise is the following. Remember, we in the previous video we talked about how to find the median using the brute force way, right? So what we did was we removed the outermost values one by one until we end up with one or two values in the middle. Let's apply that same procedure here and see if we end up with the same value for the median. Right? So here the first thing I want to do is I want to remove 0, remove 9.7, I remove 0.5, I remove 9.5, I remove 1.1, 9.1, 1.6, 8.9, 1.8, 8.6, and so on and so forth, right? So I'm going to keep doing it until I end up with one or two values in the middle. I know it's tedious, but we're getting there. Okay, so now we end up with two values in the middle. And from our discussion in a previous video, the median is going to be the average of those two values. Right, so the median will be equal to 5.2 plus 6.1 divided by 2, which is 5.65. The 50th percentile here, which is the median, is also equal to 5.65. So we're good there. In the real world, if you want to find the median using the brute force way, that's fine. If you want to follow the procedure we did here, that's fine as well. So now let's look at the definition for just a little bit. We know that based on what we just did, we know that the 25th percentile is equal to 2.8. Right? Now, by definition, right, at least 25% of the observations must be less than or equal to 2.8. And when we say at least 25%, that means 25% or more. Right? And then the second condition is that at least 100 minus 25% of the observations must be greater than or equal to 2.8. That means that at least 75% of the observations must be greater than or equal to 2.8. That means 75% or more. Let's now confirm that these conditions are met. First off, we have 8 observations in the dataset whose values are less than or equal to 2.8. Okay. So the percentage of observations that are less than or equal to 2.8, the percentage of observations less than or equal to 2.8 is equal to 8 divided by 30 times 100. That gives you 26.67%, which is greater than 25%. So the first condition here is satisfied. Now for the second condition, we have 23 observations that are greater than or equal to 2.8. So the percentage of observations that are greater than or equal to 2.8 is equal to 23 divided by 30 times 100. That gives you 76.67%, which is greater than 75%. So the second condition is also met. So we have essentially confirmed that 2.8 is indeed the 25th percentile. Now what I would like you to note here, right, is that the definition implies that the 25th percentile can be any number. So it can be any number that satisfies these two conditions, right? So for example, let's look at 3. I'm going to leave it to you to verify that if you replace 2.8 up here, if you replace 2.8 by 3, nothing changes when it comes to the percentages that we calculated. In other words, it's perfectly fine for me to claim that the 25th percentile is equal to 3. So it is perfectly fine to claim that the 25th percentile is equal to 3. Why? Because the two conditions in the definitions are still met. So what do we learn here? I'm going to put it here. So what we learn is that the value of the pth percentile is not unique. So the value of the pth percentile is not unique. Right? In fact, it doesn't have to be. Okay. In fact, the procedure that I show you to find the p percentile is not the only way to find the p percentile. There are actually other ways to find the p percentile that gives you slightly different answers, which is fine, right? As long as the definition is satisfied. So the procedure we discussed in this course is not the only way, right, to find the it's not the only way to find the value of the p percentile. In fact, there are other methods that yield slightly different answers. So in this video, we have gone through a particular example where we've found the 25th percentile, the 50th percentile, and the 75th percentile. We looked at the 50th percentile, and we have determined that it is nothing other than the median, right? And then we discussed something very important, which is the fact that the procedure that we discussed in this course is not the only way to find the p percentile. There are other methods, other ways of finding the same thing. They will give you slightly different answer, but as long as the definition is met, there's nothing wrong with using those methods.